Hi there. We'll go over Chapter 8.3, Number of Solutions for Systems of Linear Equations. From Section 7.4, Parallel and Perpendicular Lines, we noticed how two lines can have one or no intersection. So that also means there's one or no solution. We will also take a look at a third case where two lines have infinitely many intersections, as in there's infinitely many solutions. So there's a new term we need to know for this section. It's called coincident lines. So lines that occupy the same position. And in a graph of two coincident lines, any point of either line lies on the other line. So essentially what they're saying is that two lines overlap. Let's take a look at example 1. Determine if each system of equations have one solution, infinite solutions, or no solutions. So we can first take a look at the format they give us. We can solve this by graphing. So we'll check by graphing. So this is my grid. We'll graph it now. So in blue, that's a first equation, and I'm going to draw the second one in red. So let's take a look at the first one. So y-intercept happens at positive 1, so we'll start at 1. And the slope is 1 over 2, so we go up 1, 2 to the right, up 1, 2 to the right, and so on. I'll draw multiple ones here, and I'm going to connect the points. Okay, so this is what I have for equation 1, blue line. In red, I'll graph the second line. So y-intercept is at positive 3, so 3 here. And it goes 1 up, 6 to the right. So 1 up, 1, 2, 3, 4, 5, 6. And actually, it'll go above that grid, so I'm just going to stop there and connect the point. So we already know that this is clearly the intersection. So let's write down the coordinate. Coordinate is 6 and 4. But in this case, we're not really determining what the intersection is. We're looking for how many solutions we can get. So the answer to part A is just one solution. Will we ever have more than one solution here, like 2 solutions, 3, or 4? In fact, we cannot have more than one solution in this case because these lines will continually moving away from each other once that hits here. All right. For part B, let's take a look at that. So same idea, we're going to solve this by, we could solve it by graphing, but in this case, I would like to go over how to check this without graphing. So let's check their slope and compare them. So before we do that, we know that our first equation is already in the y equals mx plus b form, but our second equation is in somewhat general form. So we just need to rewrite the second equation. So let me just redo that. We want to have it in slope-intercept form. So I want to isolate y, so we're going to take away 6x from both sides. We are left with 3y minus 6x plus 9. Divide both sides by 3. Oops. And y equals negative 6x over 3 plus 9 over 3, which is just negative 2x plus 3. All right, so this is our equation 2. Let's compare their slopes now. So notice that their slopes are equal. Okay, so they're either parallel, there must be parallel, or they're overlapping. So how to check that is first look at their y-intercept. So the first equation has 3 as y-intercept, and hey, our second equation also have 3 as y-intercept. So we can say for equation 1, m is -2 and b, the y-intercept was 3. For equation 2, m is also -2 and b is +3. So this shows us that they are same lines. They are overlapping each other. Okay, so when you graph it, although it looks different, when you graph it, they overlap each other. So because they overlap, we can say they have infinitely many solutions. Or you can also say infinite solutions. On to part C. So we were given 2 equations. Same idea, we're going to check the slope and the y-intercept. All right, so the second equation is not in an ideal form, so we're going to rewrite it in slope-intercept form. So I want to isolate y, so take away 2x. And then divide the entire equation by 6. Make sure to divide each term. And let's simplify this to -1/3x plus 4. Alright, so this time we're going to take a look at slopes again. Alright, so here it is. Alright, so equation 1, slope is -1/3, and equation 2 slope is also -1/3. Okay, so it's either parallel or overlapping. Okay, so let's take a look at our y-intercept. So the first equation has 6 and second equation has 4. So we can say that these 2 lines are parallel, so therefore they're not going to intersect. Parallel lines, therefore no intersection. We can say there's no solution. There was a typo for example 2, so it's not 4. Determine the number of solutions for each system by inspecting the coefficients. So the key word is inspecting the coefficients. So coefficients are the values in front of variables. So we just need to consider the coefficients in front of variables here first. Let's take a look at part A. So notice that coefficients are all the same. So two equations are equal to each other. So this means that lines overlap. Therefore, there is infinitely many solutions. Infinite solutions. All right, so for part B, we're going to do the same thing. Check their coefficients. Notice that they're not equal, but the second equation here, when you multiply the entire equation by 3, you will get the exact same equation as the first one. So we can say that equation 1 is a multiple of equation 2. Which means that essentially the lines just overlap. Therefore, there's infinitely many solutions. Moving on to part C. So this time our coefficients are all equal, but our constants over here are not equal. So the only difference between part A and C would be the difference in constants. Okay, so the part A was indicating that two equations are exactly the same. So they're same equations, so therefore they overlap. Part C is a bit different. If the constants are not equal, this indicates that they don't have a same y-intercept. They have a same slope, but they don't have a same y-intercept. So it's important to note that because the constants are not equal, this indicates that y-intercept is different. So the two lines are parallel to each other. So there's no solution. If I were to show this by algebraic method, I can say, let's rewrite the first equation. 2y, y equals negative 1 over 2x plus 2. This is equation 1. Whereas equation 2, we do the same thing here. 2y negative x plus 10, y equals 1 over negative 1 over 2x plus 5. Notice that for equation 1 and 2, slopes are equal, but their y-intercept's different. Okay, so then we can say the constants are not equal, and the y-intercepts are not equal, therefore the lines are parallel, and so there's no solution. So this is it for 8.3. I'll see you guys in the next video.